slides, and then we'll get to our hands-on part, which is really a lot of fun. We are going to do a pH test today, and so I wanted to just talk a little bit about what pH is, and again, why it's important. And we'll determine at least a ballpark of whether your soil is more on the acidic side, the alkaline side, or perhaps somewhere in the middle. And so this is the term percent hydrogen is another way to think of it. And it has to do with the amount of free hydrogen ions that are in your soil. And if you remember that little graphic of nutrients going into the soil and some hydrogen ions going out into the soil, that's kind of how we get hydrogen ions. And so actually the more you fertilize your soil, the more hydrogen ions exit, and your soil can become more acidic over time, which is kind of weird. Also, if you have a lot of rainfall that leaches through the soil, that can eventually turn things more acidic over time, or if you happen to have acid rain. But overall, our water here is usually considered to be higher in the alkaline side. So watering with alkaline water may not be lowering your pH so much. And again, it depends on what your parent material is, etc. in there. So it will give you some insights into your soil, which are kind of interesting. So we measure the pH scale, and it goes from 0 to 14. 7 is in the middle, and usually that's considered to be neutral. But the interesting thing is because it is a logarithmic number, in reality, every time you go from 1 to 2 or 2 to 3, or whatever, just change up 1 degree, you're changing 10 times the acidity or the alkalinity. So if we're trying to get, if we have a soil, say, that has a pH of 9, and we want to grow blueberries that are a pH of 5, their preference, we've got to go 10, 100, 1,000, times 10. 10,000 times difference. That's a big change. It's almost impossible to do. It's okay to maybe try to go from 7 to 5. That's 100 times different. 10 times 10. That's a little more feasible, but you certainly don't want to have to go to these intense, rebuilding your soil, adding tons and tons of this or that product to lower your pH. Might as well just say, I'm going to go buy my blueberries. A lot cheaper. Okay. So, again, anywhere from 0 to 14 is the scale. However, most of the soils are going to be somewhere between here and here, between 4 and 9, roughly. But every plant has a preference, and there are charts and guides out there to let you know, for instance, that blueberries prefer it more acidic, or, gosh, I can't even think what likes it more alkaline. Anybody know anything? Azaleas, acidic.
Roses.
Roses.
Hydrangeas.
Hydrangeas, yeah, you can change the color of them when you change your pH. That's another thing that's kind of interesting about it. Just to give you an idea, this is looking at it a different way. Hydrochloric acid is 1, very acidic. Lemons and vinegar in the 2 to 3. Tomatoes are 4. We often talk about low acid tomatoes. They tend to be kind of acidic. Towards the neutral area, we get into things like milk, seawater, bicarbonate of soda, milk of magnesia. These are all things that help to settle in those acids and neutralize excess stomach acid. Remember those commercials? That's what's going on with those. And then ammonia, and then up 13 is lye. So we're getting into very caustic things when you get to the extremes. Okay, so most of our plants, again, are going to kind of like it in that middle range. Now, one of the interesting things is depending on your pH, you're going to have more or less nutrients that are available or soluble at that point. You can end up with some toxicities, and you can sway the type of flora that you have in there. In other words, the microorganisms. Some of them have preferences for pH. There's a famous one, I think, with potatoes, that if they grow it in a more acidic type of soil, you eliminate a particular type of disease that wrecks most potatoes. So if you just alter the pH of your soil, you don't even have to deal with that particular disease organism. It's just hostile to it. So you can sometimes make things happen for that. Okay, So you probably saw a chart like this in your book that shows you these different bands of nutrients and where they are mostly available. So as the band gets wider, that's where that nutrient is available, and where it gets skinnier, like in the case of iron here, the more alkaline you get, the less available iron is. So if you have a plant that likes a lot of iron, like azaleas and blueberries, they're not happy up there because there's not enough iron for them. Okay? So we typically say that in this sort of middle nutrient or neutral range, we've got nitrogen, phosphorus, potassium, sulfur, all nice thick bands here. We still got a little bit of calcium, magnesium, especially as we get a little more on the alkaline side, a little manganese, boron, copper, and zinc in this area. But we're beginning to come up with deficiencies of our major nutrients over in this area. So if we're very strongly acidic type of soil, we're going to be deficient in these major macronutrients. So we don't want to get into that situation. So we want to try to keep our pH balanced, but to match the preference. And again, as we get up here, strongly alkaline, some of our trace minerals become deficient. This is an old one that we used a lot when I was in the Midwest, and I kind of like it. It maybe is a little difficult to see here, but you can kind of see teeth here between the calcium and the phosphorus and the phosphates. And what's happening here is these are binding together and becoming less available at that particular point. And again, aluminum actually at low pH may become extremely toxic. It becomes too available and causes problems with plants that are sensitive to aluminum. Things like some of our palm trees, if they like, a certain nutrient, let's say magnesium or manganese, sometimes that can be deficient at these higher pHs. Or if it's a plant that needs molybdenum, again, it's too low there, but maybe it's too high over here. So we've got to kind of watch excesses as well as deficiencies on these things. I was in a place once where we actually had boron toxicity, which is kind of weird. I think it was leaching out of the foundation of a building, but kind of a strange thing that can happen every once in a while. Okay, so as far as the actual nutrients go, we're not going to be testing for those, but I want to just kind of buzz through these a little bit, and it may get to that question on chlorine here as we go. I can't remember exactly, but plants need nitrogen. They need it for photosynthesis, and most of it occurs in the leaf. It's an essential part of protein. Okay, so the higher amount of nitrogen you have, the better the content of protein is going to be in that particular crop. Typically more present in younger leaves, and just talking about the ratio here between older and younger leaves. And in nature, it's typically the limiting factor for plant growth. So if things are just growing out there and they seem a little bit pale, or they're not growing very well to the size, it may be that there is a lack of nitrogen, assuming everything else is okay. And then you add a little nitrogen to it and see what happens. If it improves, then you know that was probably the clue. So if it's short, stunted, pale, or chlorotic, as we say, the leaves are smaller, we have overall yellowing, and those older leaves start to lose green color first, then we kind of know that that might be a nitrogen deficiency. And showing here some, it's a little difficult to see here, but you can see some difference in color, especially probably on these palms. This is deficient, and that has adequate amounts of nitrogen. So this one's a little bit bigger, a little fuller, and obviously a much darker green color than those are. Now it's going to show up differently on monocots versus dicots sometimes. And again, you can see the ones in the foreground are much paler in color, and they're not as thick as the ones in the background. Corn is a plant that shows up that deficiency really well. So the monocots really show that up quickly. And you can see what happens to turf grass. Back here, this is adequately fertilized. This is not. You begin to get other plants coming in and competing. It doesn't look as healthy or as dark green. And then also corn, if it's deficient, it'll start to show up rather quickly. That's sort of the poster child.
Question?
Yes?
Does a plant absorb differentially ammonium ions versus nitrate ions? Which one is preferable, and at what pH are those most absorbed?
A pH question I don't know. But I do know that it can take in ammonium ions, which are positively charged, and also nitrate ions, which are negatively charged. I think it uses less energy to take up the nitrate form of nitrogen, and it has to go through another kind of change, I think, before the ammonium nitrate. It takes a little more energy to get that assimilated into it, from what I understand. Yes?
How long does it take generally for the plants to respond to the corrected nature?
Of nitrogen, it can be fairly quick. Yeah, especially depending on how it's delivered. You can actually do foliar sprays that give you a really quick response. You may notice if you have a neighbor or somebody that gets a lawn care treatment, and they're going to have this really deep, dark, vibrant, kind of dark green color, and the next door neighbor that didn't get the treatment won't have that. Okay, so you can actually see it very clearly, and sometimes within just a matter of days, depending on temperature, depending on microorganisms, and depending on the product that's used, because sometimes it takes either microbes to release the nitrogen or water, rainfall, etc. to release it. And so depending on the situation, but there are some that are quick release and some that are slow release forms. Okay, phosphorus. Now this one usually takes a long time to respond. It's not as mobile in the plant or in the soil. It isn't always deficient, but it does help with root growth, efficient water use, resistance to cold and disease, and we typically think of this as the one that does the blooming and the fruiting and getting the plant, to produce for us. So flowering plants, we typically say, need more phosphorus than, say, a turf plant. It's primarily limiting in tropical systems where they have highly weathered soils. So it usually leaches out or has been degraded out of those soils. If we have a deficiency of it, the plants are stunted. Sometimes the actual foliage turns a little bit purple in color, and it may have delayed maturity, so it may not flower and fruit if it's deficient, or we might not get any flowering at all. Now, the best place for plants to get phosphorus is from organic matter, and it can come from the weathering of minerals in the soil, but a lot of that is fixed and unavailable. And again, at those extremes of pH, that's a problem, but if you have the neutral pHs, it's a little bit more readily available. So calcium phosphate, orthophosphates, or clay particles and organic matter can give you some of that. But again, it's not mobile in the soil, so it doesn't move. So they typically say, sometimes you'll read and it says you should apply it in bands right near the soil or the roots, or perhaps even incorporate it into the soil in the root zone, because once it's there, it pretty much stays wherever you put it. It doesn't leach or move around a lot. And again, the plant will use about 10 to 30% of what you apply, but it's going to store the rest of it somehow. And again, pH management helps avoiding those extremes. So again, it may reduce the vigor, it may delay maturity, it's going to reduce the bloom. So this is a canola oil field here showing where you've got adequate amounts over here, but not enough in this particular situation. It looks nice and dark green, but you want it to, have the seeds and the flowers in order to get the oil out of it. So that can be a problem. And this is what it looks like in a monocot. It's kind of interesting. When you look at that, you go, is that a disease? Is that a scale insect? What could that be? And so you have to know a little bit about, was that adequately fertilized? Is that maybe the pH is wrong and it's not letting it be available? Up top looks like tomatoes, and then down below is corn. And again, that purpling is very evident on the corn. Now, potassium, again, it's going to help ripening. It's going to activate enzymes, strong growth, better disease resistance. Water stress, it helps a lot with our drought situations. And when it's deficient, you're going to have problems with root systems. It regulates the amount of water going in and out of the cells, so it's important for that. And you can get scorch on the leaf tips. Now, scorch on leaf tips can be caused by a lot of things, but it could be one of the symptoms of this. Now, it moves in the soil, not as much as nitrogen, but a lot more readily than phosphorus. And it will, again, help plants be more resistant to infections. Again, a little bit of that yellowing around the edge on soybeans, kind of what that looks like. And again, even though we don't grow soybeans here, just think of most dicots, okay? So usually we'll show some differences between things. Again, soybeans we don't think of much, but this is what it looks like with 0 potassium. And then we've got beets and barley. I don't want to go through these a lot, but when you start getting in some of the secondary macronutrients, we start to see what's called interveinal chlorosis, where the veins will stay dark green, but the spaces in between are going to become yellowish in color. So these are signs of some of these deficiencies. So it could be magnesium deficiency, it could be iron deficiency, manganese, depending on the type of plant. So again, showing you a Phoenix robellini with that, and then some tomato plants, what that looks like. Let's see. Some of these trace elements, I guess we aren't getting into chlorine here. Sorry, we might not be answering that question. But one of the things here, if you have too much, you can get toxicity. But if you don't have enough copper, your citrus might not be sweet. Okay? Interesting. Lots of other reasons why it might not be. Not ready, not enough warmth, not enough sun. But it could make the difference in some cases. Here we go. So chlorine is an anion, so it's negatively charged. I guess I don't have any comments about that so much. Let's keep going. Maybe we'll see that. But again, boron deficiency. Again, it's not well understood, but it can cause weakened cell walls, death of the terminal buds, blackened hearts. I guess that depends on what you're growing. Hearts will fall, maybe, I'm not sure. May hurt pollination, but too much is not good either. So these micronutrients you have to be real careful not to add too much. If it says add 1/4 of a teaspoon per whatever, do that. Don't say, oh, if I add a tablespoon, it'll be better. You could really throw things off because you're dealing with tiny amounts. Oh, here we go. Not well understood. All right. Plays a role in photosynthesis, acts as a solute, can occur in toxic levels. So again, the main thing is little goes a long way with that. Molybdenum needed for nitrogen metabolism and nitrogen fixation, which is a bacteria that lives on the roots of our acacias and other things. The bacteria are the ones that can fix the nitrogen and improve the soil. And then crops in the mustard family may be sensitive to that. Good to know. Iron deficiency, this is one you might run into if you're too alkaline. Our acid-loving plants aren't happy when they don't get that. And again, usually younger leaves are pale, the older leaves stay green. And usually that happens when you have a nutrient that's not very mobile. It formed in those older leaves, but when the new growth happens, it's not leaving to go up to that new growth point, that meristematic growth. And so it's what we call an immobile nutrient. And so you would need to add more, or you may even do a foliar spray, would help a lot. Bypass the roots. There's an iron deficient palm, zinc deficient corn. Again, you maybe see a little striping there. So it's hard to get good pictures of some of these deficiencies on plants that are common to us. But if you have boron deficiency on a rose, pretty gnarly, or on a cauliflower, not pretty at all. Molybdenum deficiency on melon, zinc on citrus. So if you are growing citrus, you'll probably buy a product that's labeled for citrus, and it has usually the correct amount of trace elements and the ones that are most commonly needed. Palm fertilizer, again, is going to be specially formulated for what's typically deficient with the palms. Magnesium deficiency on Schefflera, and, manganese, there's a difference between them, it's a micronutrient, and then, again, it happens a lot in the alkaline types of soils. If you have too much, though, phytotoxicity can occur on coffee and rose. And then herbicide damage, another thing that you can mistake for some of these nutrient deficiencies. So if you've got a lot of curling and distortion of the leaves, and you know that somebody's been applying some herbicides, you may want to go that direction instead. And you can see they've just changed the shape of a lot of these leaves and kind of taken over some of their metabolic processes. Mosaic is a virus, and again, you'll deal with this if you haven't already in diseases. The spotting could look like a nutrient deficiency, but it is something that's peculiar to roses especially.